Assalamualaikum and welcome to our video presentation.
My name is Danish Fahmi. I will start with introduction about composite armor. Have you ever wondered what soldiers wear when they fight? Do you know what is composite armor in military? Composite armor is critical to modern military strategy, allowing vehicle and personnel to maintain mobility and survivability in increasingly complex and high-threat combat environment. Composite armor is a type of advanced protective material used primarily in military vehicle and structure. Here are the key purposes of composite armor in military are: first, enhanced protection. Composite armor is designed to protect vehicle and personnel against a wide range of threats, including armor-piercing rounds, explosive projectile, and shape changes. It absorbs and dissipated impact energy, reducing penetration and internal damage. Second is weight efficiency. By combining lightweight material like ceramics, polymers, and metals, composite armor provides robust protection without significantly increasing the weight of military vehicle, improving mobility and fuel efficiency. And lastly, adaptability to threats. Composite armor can be customized or upgraded to counter specific threats, such as modern anti-tank weapons, making it versatile for different combat scenario and mission requirement. Next, we are going to background and history. First, we start from World War II. The first layer, armor concept, emerged as military vehicle needed improved protection against anti-tank rounds. Early attempts included basic multi-layer steel design. Next, post-World War, research into material like ceramic and polymers begins. Driven by Cold War innovation, these materials show promise in absorbing and dispersing energy better than steel alone. After that, in 1916, developed in the UK, Composite armor became the first widely recognized composite armor system. It used layers of ceramics, metals, and synthetic materials to protect against both kinetic energy penetrators and heat rounds. Lastly, in 21st century, lightweight, flexible materials such as ultra-high molecular weight polyethylene, UHM, WPE, and carbon fiber composite became integral to personal protective gear and vehicle.
Thank you, Daniel, for giving us a brief explanation about composite armor. I am Danish Hakim, and I'm going to talk to you about real-life application of composite material in armor. Before that, I think we should know what is the advantages of composite armor. There are a few that help in our industry, which is lightweight, high strength to weight ratio, durable, and most importantly, flexible. And as I talked about our industry, there are a few sectors in our daily life that use the composite armor. So, one of which is military, aerospace, and last but not least is civilian. First is our military application sector, in which the body armor that the soldier are wearing are made from the combination of Kevlar and ultra-high molecular weight polyethylene, the UHM WP, which we will discuss in a second. So for our vehicle armor, the protection layer of the vehicle itself are made from the ceramic metric composite, aerospace and aviation sector. The military helicopters such as AH-94 Apache helicopter use boron carbide ceramic as its protective layer. And another example in our aerospace and aviation, unmanned aerial vehicle UAV such as MQ-9 Reaper use carbon fiber reinforced to protect them from enemy strikes. For our last applications that we will talk about the civilian sector. So our bank security uses composite armor for the safe vault and ATM. This can keep all the money from being stolen by the thief. So in our automobile industry, armor car solution for our VIP and law enforcement uses this composite armor to protect them from any terrorist attack or another unfortunate event. We're done talking about the application. We will move forward to the example or real life case study about the composite armor. There are two in total, in which we will talk in this slide. So, first one is the UHMWPE in ballistic vest, used in a ballistic vest due to their high tensile strength and lightweight nature. The second one is graphene in a lightweight armor. There are still research ongoing into the graphene-based composite for ultralight body armor. First is that UHMWPE in ballistic vest. The implementation is that the US military produced vests made from Spectra Shield, ultra-high molecular weight polyethylene composite, reducing soldier fatigue while enhancing protection in the war zone. The challenge to overcome is that the early vests were bulky and restricting movement. By layering UHMWPE with aramid fiber, our scientists have achieved balance between flexibility and protection. So last is the graphene in lightweight armor. The implementation is that graphene sheet embedded in polymer matrices have shown promise in stopping high-speed projectiles such as bullets. There are a few challenges to overcome, which is the initial production costs were prohibitive, but the advancement in the manufacturing technique have reduced costs significantly. So that is all from me about application and example in real life.
Assalamualaikum, my name is Muhammad Admin Fitri bin Mahdi, and now I'm going to talk about the advances and innovations of composite in armor. Now let's talk about the advancement and innovation of ceramic-based composite. The ceramics such as boron carbide, silicon carbide, and also aluminium oxide are widely used in a hard armor system because of its exceptional hardness and lightweight properties. These innovations are functionally graded materials where it can go from hard to soft, and this can maximize the impact absorbed or reduce the spall or fragmentation. The second one we have is transparent ceramic called aluminium oxynitride or ALAN. This material are used for bulletproof windows. This material are resistant to a high velocity projectile. Next we have a fiber reinforced composite. The advancement of this composite are focused on ceramic fibers such as Kevlar and ultra high molecular weight polyethylene like Dynamo. These material are used in a lightweight body armor because of its high tensile strength while remaining flexible and also lightweight. Its innovations are hybrid fiber system where the aramid fiber was combined with UHMWPE to improve the ballistic resistance while maintaining flexibility. The second one is the nanotechnology enchanted fiber, where they integrate carbon nanotubes in a graphene into a fiber composite. This will significantly improve the impact strength and also energy dissipation of the fiber material. Last but not least, we have smart and adaptive composite, where its advancements involve the integration of shear thickening fluid into flexible fabric like Kevlar. This provides multi-thread protection. It will harden upon impact to stop bullet or knives. The innovations of this composite are self-healing composite and also the integrated sensor. For the self-healing composite, it's able to repair itself by using embedded healing agent. This can make the composite last longer. For the sensor, it was embedded into the composite to allow real-time monitoring of damage and threat detection. Now let's talk about the future trend of composite armor. First, we have a smart armor with a self-healing mechanism. It can repair itself when damaged using a special material. It can also change its shape or become stronger depending on the impact it took. The impacts of this smart armor is to make armor last longer and also improve the safety of soldiers and also guards. Second, we have a hybrid armor combination for multi-weapon defense. This armor was combined with a different materials such as ceramics and metal. It can protect the wearer from the bullet, explosive, and also chemical while being flexible and lightweight. Last but not least, we have a wearable tech in armor. The technology such as sensor was inserted into the armor to track the wearer's heart rate. It also can be used to detect the surrounding danger. This will keep the user connected and aware of the real-time updates. With this, the soldier can stay safe from the danger while also have their performance improve.
Okay, next we go for the benefit and advantage of composite material in armor. Composite material in armor provides several key advantages, making them the ideal for modern application. One of the primary benefits is their lightweight nature, enhanced mobility for soldier, and improved fuel efficiency for the vehicle, while also reducing fatigues during the extended use. This material also offers excellent thermal resistance, allowing them to perform reliably in high temperature environments such as combat zone or aerospace operation. In terms of sustainability, the reduced rate of composite lower fuel consumption contribute to decreasing carbon emission and ongoing advancement in recycling technology, and are making them more environmentally friendly. Additionally, the design flexibility of composites allow for the creation of complex shape and customized armor solution, and also improving comfort, functionality, and adaptability to specific needs. This style also enables the integration of the advanced features such as radar absorption further enhance their performance in different applications. While composite material in armor offer significant benefit, they also come with the challenge. One of the major drawbacks is the high cost. The raw materials such as carbon fiber and ceramic are expensive, and the manufacturing process is complex, which drives up the production costs. Another challenge is the complexity of the repair. The damaged composite are difficult to fix, and in many cases, the entire damaged section need to be replaced, leading to the higher maintenance costs. Lastly, the temperature limit can be the limitation while composite perform well under moderate heat. Certain polymer-based composite can weaken or lose their structural integrity at a very high temperature, restricting their use in extreme environment like fire or high energy explosion. This challenge highlight to be need for continual research to improve the affordability, repairability, and thermal performance of the composite in armor application.